Okay, so we're starting. We are live. It's being recorded.
So who's being MC today?
Captain Mike.
Captain Mike. All right. Well, welcome to our weekly hangout on Google+. I am here today with Abraham Vassant and Russell Cox of Flexure Engineering, and today we're going to be talking about the communications architecture and the needs for setting up a communications architecture in cislunar space. So this is going to be a bit exploratory with Abraham and myself going over our needs and capturing the different aspects of the system that we want to put into the architecture. At least that's my understanding of what I'm going to be doing today. Abraham, do you have anything else to add to that?
No, that's pretty much what we want to talk about today, and thank you.
All right. One of the main things that we're going to come out of today with is a table of aspects, a matrix of sorts, and we're going to go over our discussion of that table, and we're going to come to a better understanding of what each of us is after here. So let me pull up. I'm going to pull. Abraham, you muted me.
Apologize, I was trying to mute myself.
All right, let me find out which guy. All right. Okay, I'm sharing our notes, which are essentially our private minutes of our weekly hangout, and this is where we're going to be putting our table. All right. So let's go ahead and get started. So what are some of the things that you're looking for in, let's see. Thought this would just work. Okay, well, let's just get started then. Well, tell me, Russell, what are you looking for in some of the aspects of our communications that we're looking at?
So what we've talked about is the idea we definitely want to recreate the cloud in deep space, or at least cislunar space. So one of the goals there is, apparently seamless communications, so that when you're on the internet and I send an email from my laptop to somebody else's laptop, a lot of complicated stuff happens. In the old days, I needed to know some of that. Today, I need to know next to none of it. Whether I'm doing a video or a text or an email, all that stuff in the modern world on your phone or your desktop happens more or less without the user knowing anything about the actual network itself. And right now, my understanding is DSN and other type of space communication systems are even kind of pre-internet, in the sense that you have to, they're more like the patchcord phone system of, you have to really know an awful lot of exactly what route things are going to take and set it up in advance and go in and plug it in when you want to use it and unplug it when you're done. So that's one of the first objectives, is to try and get all of that infrastructure out of the way of the user. Mike, are you there?
Yes, I'm here. Generally when you're talking about your communications plan or your communications architecture for a mission, you can talk about crosslinks between the different spacecraft. You talk about whether or not you're going to have, say, an omnidirectional link versus a high gain or directional link. And for a lot of the things that we've been talking about, it's the directional link, which is has been the mainstay of the communications. And you mentioned DSN. You mentioned DSN. Those are some pretty big dishes that you have on the ground, and those for deep space, they talk about having on the spacecraft a low gain antenna and a high gain antenna. That's still pretty a rather relative measure there.
Yeah.
So when we're talking about setting up the cloud, and you're talking about different nodes, you're going to have to have some understanding of, say, what the physical layer is going to look like. And there's a big difference between, say, what the physical layer of a terrestrial network looks like, and say what it's going to look like for your constellation of spacecraft.
Yeah, my expectation is the first layer would look something like we have a carrier. It may have the trunk line down through DSN, and the operator of the carrier has to do things the current way or the old way. But then you have, pardon me, 10 or 20 CubeSats that are released by the carrier that probably talk to the carrier first, and they have the more modern cell phone-like network where they can talk amongst themselves either through a star network on the carrier or maybe even peer-to-peer as they're operating in a swarm mode. So probably the first way we can create an experience for the users that's pretty organic would be in that model is that somebody is organizing the carrier with 10 or 20 CubeSats in it. That person sets up a local area network that the different CubeSat users, of course they're using software interconnects, but it feels and looks an awful lot like a terrestrial local area network and not some complicated deep space network. And that probably could be built into, so we'll probably talk about it a little more today. One of the models of that is the Space Systems Loral has these the opportunity to get a 90 kilogram box or a 150 kilogram box to geosynchronous orbit. So one of the concrete carriers that we're looking into is a carrier that would fit into one or the other of those boxes. We know that Deep Space Industries is also looking into building a carrier that has this model where in the 150 kilogram box, it's released at geosynchronous, it goes off to somewhere in cislunar space, and it deploys a handful of CubeSats, and then it provides the communication services back to the ground and the propulsion services to get you to where you're going. So coming up with, and my bet is, maybe we'll ask Abraham about this, my bet is the current CubeSat model has nothing that even begins to look like a local area network as part of the CubeSat specification. So one of the first things we could do as a SIG, as a group, is say, okay, well, let's imagine that we're going to create a local area network amongst the CubeSats so that they can operate in a swarm at, say, a kilometer distance. And they do either peer-to-peer or peer-to-carrier, so it's either a star network or a point-to-point network. That could be something that could be fairly quickly defined and characterized, I would think. So, Abraham, you're right?
Yeah. Yes, most of the layer 0, or let's start with layer 1, 2, can be highly modeled with the terrestrial-based implementation. And when you kind of change the antenna and the final gain output amplifiers, they essentially become, the Wi-Fi range becomes several kilometers, for example. So that part does not seem to be posing much problem. The area which, and more or less to go along what Russell sees, Not all things will be possible, but many things in principle or by equivalence this will be workable.
Now,
And
what sort of Wi-Fi ranges are you talking about?
say about 40, 50 kilometers. But we may not call it Wi-Fi. It may be sci-fi, like a space-fi or something. Yeah, essentially, when you kind of peel the layers of 802.11 and the lower layers, which is 15, like 0.15, 16, they're the ones who go closer, like the encoding layer to the data carrier schemes and things like Zigbee.
Right.
There's quite a lot of layer 1 and layer 2 models already exist in the terrestrial applications.
Right.
So if like say, for example, take the Zigbee media and can you plug it into the data link layer of the Wi-Fi? Yes, that's such things are already done. So we're still in compliance, but we have to kind of revisit the compliance factor when we come back to space needs. But in principle, yes.
Right. The when I was doing some swarm robotics, when I was doing swarm robotics, and we were looking for sort of a robot area network, if you will. Zigbee came out very well as far as the different area networking schemes went, and so I probably have to refresh our thinking about what is available. But Zigbee was definitely a good one for sort of a multi-node network. And I do understand that if you're in a relaxed regulatory environment and can put some power behind your transmitters, you can get some good range with that sort of scheme. The one thing,
just to add in the mix, you're also probably familiar with WiMAX. Okay, they're already kind of 802.11 derivatives, but the physical layer spec'd out in either 11 or 15, I think, 15 or 16. That goes up to several miles, almost like 5 miles to 10 miles range. Okay, so
that's terrestrial. That you're
that's terrestrial. Yes. If you put a little booster and a bigger antenna, you can go quite a long distance.
Right.
So what I find is, around that area we have several options and flexibilities.
Right. One thing that is, well, a couple of things come to my mind, and in general, crosslinks are hard because they're in general resource hogs. In a number of different ways, they take power, they take pointing. For you choose, for any given reliable bit rate, being able to communicate from one spacecraft to another, that's an important architectural driver. And part of it is because the distances can get to be pretty large, and that brings me to the other part, which is say the dispersion in the orbits. It's all nice to say that you're going to be talking about things that are a few kilometers apart, but what you really have to do is to look at the orbital mechanics and look at what your constellation or formations are going to look like over time. I don't know if for a lot of the applications, at least early on, that you're talking about, you're not talking about I don't know. you may not be continuously thrusting, and so you may not be able to go into these non-Keplerian sorts of orbits that are giving you they're giving you a what we might consider to be a nice geometrical formation. And that isn't the way orbital mechanics works unless you're willing to pay for it. So if you look at your orbits, because each spacecraft, each asset, is in its own orbit around the primary object, like the moon, and they're going to be following that orbit. So and each one is different unless they're in that so-called string of pearls that Pamela likes to talk about. So if you're going to be coming up with link budgets and distances between the different spacecraft and bit rates and things like that, you're going to have to put down some ideas about what these formations are going to be doing. As just as they move along their trajectories. Now, another aspect of that is that we're not always going to be talking about spacecraft that are in similar orbits, but they could be in very different orbits, and I think that's part of the vision as well. So you can have very different orbits, and also things on the surface, which points out that you're going to have things perhaps moving into or out of communications range, unless you're talking about some special architectural considerations. So I'm seeing that there are some big parts of this vision that we can that could be sketched out or need sketching out, so that you can start to talk about, well, what's possible, what fits in the various cube factors that you're talking about, and how these things would be added to the assets that we know are going there in the next few years.
Yeah, thank you for that, because I think that lays out and part of what I expect what we want to do is pick a couple of simple architectures that clearly will be used by somebody someday relatively soon. And so the idea of like the string of pearls model, where everybody's in the exact same frozen orbit, they're just phased slightly differently. And you can imagine that you communicate up and down the string of pearls is more efficient than maybe one or two of them are large nodes that can get back to Earth or get to the ground on the moon. But all the other, many of the other things have been kind of like the A train around Earth. There's an orbit that has, last time I looked, like 6 or 7 different observational satellites that are in the same orbit, so that they all are looking at the same thing, just in slightly, a few minutes after the previous, and so they can compare their data in near real time. And so there are examples of these strings of satellites doing semi-collaborative operations. What we'd want to do is improve that. And then also the other model that jumps up is the delay tolerant kind of donkey model, where all these satellites do a burst download when they're like over the South Pole and there's a big lander there, and then they trade their mail bags up and down, and then when they're far out in the distant parts of their orbit, they're out of communication. So there's I think you're right. We could probably pick 2 or 3 operational modes and explore the limits. The first question is it a kilometer, 10 kilometers, 100 kilometers? The standard lunar orbit people talk about is a 100-kilometer orbit. So communicating from the surface up to a 100-kilometer orbit is one milestone to look at. What does that take? And that's farther than we've been talking about in terms of local Wi-Fi sort of networks.
Yeah.
Go.
I would like to chime in. Do you see my screen? Like, how do we do that? Can I show my screen?
No.
Yeah, we see the lunar proximities slide. And
correct. So also to address Michael's valid points, these are some of the references for our purpose that we redefine, like the CCSDS and NASA has a definition of proximity A, B, and NASA does it differently, CCS does it slightly differently, but they're talking about Earth-Sun distances and multiples of those, you know. But what we're talking about is for the lunar network, we kind of redefine this so that if it follows like in a close proximity for docking purposes, and they're so close, sometimes like the ducks when they fly, they keep going on chatting, but the formation of the ducks, I don't think, or I don't know if there is a long distance protocol with another cluster of birds flying. So in similar thoughts, if at all that's necessary, then we can have a jump into the next hierarchy, like the near and far, and the geo and the GSO also we can have a characterize. And most of the part of the work which I'm already doing, Michael, is to kind of narrow down and identify different technologies and the limitations and adaptations into the space TCP/IP protocols, and all the overheads identified and additional resources like their whether they need to hop through a hub like a topology or a switch like a device or like a router like a smart intelligent ones. And if there are nowadays, although they are talking about application routers and things like that, they also end up snooping all the way down to using the deep packet inspection methods, or like the voice over IP aware protocols. So under this name enabled and aware, there are a lot of inter-layer complexities that is hidden, and they're usually dangerous. So I'm looking into those parts as well. Hopefully I can show some light. Back to you, Michael.
Well, one question, just taking a look at your chart there, one question that I have, or that occurs to me, is that there's a very dynamic nature to the sorts of networks that you're talking about, or potentially a very dynamic nature, with a changing network topology, which I don't know. Maybe this is a good question for you to expand upon sometime.
Yes, I will do that.
You have a potentially continuously changing network topology with different sorts of link parameters, and that seems to me to be a rather interesting network or routing challenge. And you found a few things associated with that, the various store and forward techniques, but there seems to be a rather interesting technological problem about how to go from a dynamically changing set of network nodes, always changing topologies, different communication rates that are also always changing, and then achieving the sort of presentation to the user where the user service doesn't really need to care about all of that. The network is smart enough to know when it's going to be able to communicate and where it can communicate and how to deal with the dynamic and moving nature of all the elements of that network topology.
Yes, that's where you and I will lead a key role of decision making or guiding parameters. Like if you take today's cell phone, they already have like about 4, 5, 6, 7 radios in them, and they kind of shuffle around and remap the capabilities, and they do that all the time. And when particularly the timeouts or when to determine it's time to switch, that type of decisions are right now on a terrestrial-based experiences and some programmable parameters, which the threshold is how bad can you tolerate, and that's the service we will give you for the money you pay. Okay, and while our criteria has to be a little different, knowing these are going to be the restrictions and uh, the infrastructure around, not so much how the tolerance level is not our criteria, is like the effectivity of getting the bits down and up. Some, like you said, we are going to have plenty of autonomy on almost every node, and when you implement some parts of spontaneous routers and providing itself as a infrastructure for the next hop, will kind of bring some of the complexities up. At the same time, overall effectivity will be tremendously improved. And there is challenges, and that's what you and I going to do.
Yeah, one thing that jumps out at me from that discussion is the yeah, you can look at it from kind of either end of the telescope of commercial networking systems like your cell phone have an enormous amount of value to bring to space applications. And so bringing more commercial companies into building the space network would be very valuable. Or you could flip it around and just simply say that when you look at what's already in your cell phone, either from the operating system that manages the apps or the operating system that manages the communications, those are so far in advance of anything, any spacefaring, whether it's NASA or ESA or even a private space company, they're just, it would take them decades and probably never to really recreate what's already going on your cell phone. So that there's a clear advantage to adopting off-the-shelf technologies and trying to get the hardware to be tolerable of the deep space radiation or whatever it's going to take. But the lead in commercial communications is such that, and essentially cell phone design, and the fact that they get to spend billions of dollars every year trying to make it better. The space community is small compared to the telecom community at this point, and so that opportunity and the need to build a bridge from terrestrial telecom methods and technologies into space telecom is clear.
Michael, to your notes, I will also like to mention who's this guy? Dr. Riza from University of Toronto. He's doing phenomenal work in, I'm referring it as a community of assets, intelligent assets, but he's got some real interesting work going to do with robotic automation in space, more like a swarm intelligence, the word Russell prefers, but I forget the specific word they use. That's essentially like ants building a bridge with their own bodies over a small canal of water or something, and another ant using that as a bridge to take leaves across. These
Right.
they kind of I don't think we have evolved up to that level, but something like that is in the works of Dr. Riza when I was kind of reading through some of these works. So,
Well, as a metaphor, what you're describing there is something that you're really trying to do with with the lunar network. You have multiple nodes which are responsible for different parts of the communications process, and you're trying to figure out how to get them to coordinate that communication. So, one of the questions is how capable is each ant, and how far will each ant be able to reach in order to in order to perform its service, like communication. And to know that, it's going to take some thought and scenario gaming, if you will, to find out what's going to make sense. And when we're in this startup period, we're going to have some boundary conditions, and those boundary conditions are going to be the conventional spacecraft that we're putting together, and the very pointed pointed needs of those particular missions.
Yes, I think I fully agree with what you're saying, but on the long-term vision, we also have some node level definition that's going to be defined. Okay, so in this, I'm coming to this one moment, like it's taking some time, and in this particular, which was part of the poster.
Yes.
Okay, so I'm kind of how do you come? Oh yeah, you see my screen now?
Yes.
Okay, so in somehow in the time frame like 2015 later, we're going to be starting to define this lunar cube node, although we are not insisting that every CubeSat that flies has to be like this at all. Okay, these are all a set of recommendations that we learn from the CubeSat community, and we learn from the robotics community, we learn from the communications experts, and kind of graft them into multi-capable, I would say, kick-ass satellites, or like space assets. So along this line, we also, you kind of touched upon a point, so I don't want to lose that one, is coming there. Yes. This is a very simplistic X-ray view of the nodes and implemented functional blocks, both in hardware as well as software. In here, we have something like a SIM that carries its identities, and a structure, the structure defined there, it will also kind of advertise its capabilities, and it will say which cluster or group that current mission it is attached to. So it may be unwilling to share its resources for some other community until that mission is done. These are the type of autonomy that I see you have done a lot of work. So putting our brains together along with other experts, we think we have a good case that in the years to come, either we will lead the industry or at least support somebody who's promoting this, or like we'll kind of we'll figure that out. But I'm pretty think that's like in the green here, it shows the shareable resources, and this is a SIM module that's sitting in a phone-like device. And if you strip out the field, more or less 60% of what is currently populated already makes sense, and it has criteria about power management and using the power justifications is very well defined here. And since we are saying we are going to be able to lend ourselves, like my cell phone want to use your cell phone in the proximity as a speakerphone, yes, it's possible today. Okay, so I'm saying these kind of things will be quite possible in the years that we are talking about. So that's my two things. So even when among the cluster of just imagine this, each of these blue entities are 111 ant, and among that somehow a lead node takes the role of the current mission, and in order to execute trickle down, who holds whose hand out and who's stepping on whose shoulders to climb up the ladder, all those kind of can be algorithmically executable functional definition. So I talked too much. Back to you, Mike.
No, that's good. One thing you brought up in there that was that hadn't come up before, you talked about power management, and that's another example where cell phones have extraordinarily sophisticated power management systems. And it's unreasonable to expect JPL or anybody else to be able to really come up with something that sophisticated, even with a NASA budget. So I think that this idea of, because other people have said, you know, why would you put a cell phone in a CubeSat? It's got all this stuff you don't need. And I think one of the things we're pointing out is actually you need all this stuff. You need really sophisticated power management. You need really sophisticated radio management. You need sophisticated internetworking and interoperability. So in fact, no, the opposite I think is true, that starting with an Android or an iPhone or an iPad kind of as your base system, and certainly the thing you want to get to, maybe you end up chopping out certain aspects that you don't need, but I bet we're going to need a lot more than most people are thinking. So that I don't think a cell phone is in fact overkill at all for a CubeSat.
One of the interesting things that comes to my mind is that you even talk about, say, the display technology that comes with those things. Seems to me that you might even figure out a way to use that for, you know, I don't know, communications, even though they don't subtend a very big angle, but it's still something there that it might be pretty useful.
Yeah.
One interesting thing, well, you know, we can take some of these things offline. For example, like some of the modulated mirror ideas for doing, say, sort of for doing an active laser comm. So some of those could be rather interesting, and perhaps maybe even enabled with some of the with some of the cell phone technology, if you're clever about it.
Yeah.
One of the things that I keep on coming to with the discussions that we're having is that I look at the tool. I think about modeling. I think about coming up with defined scenarios, you know, starting out at a fairly low level of fidelity and working our way forwards for a couple of different models that you can start to talk about in detail and start to work towards a closed solution or a closed case on different technical questions. And one of the things that we saw last at our LunarCubes workshop a couple of weeks ago was the STK add-on that Alanex was putting together for their space network analysis. That was a very interesting capability that they were talking about, and I don't know where precisely they're going with it, or who they're working with, but they seem to be reasonably far along with the development of that SDK plugin, or perhaps Russell, you or Abraham have another thought about that particular effort.
Abraham knows more of the technical details, but one, I think that they have some financial backing and they're going to continue moving down this road. One of the things that jumped into my mind as you were doing it is that's an example of some place where we could create some competitions or games or training scenarios where we're getting, you know, quite sophisticated people to come in and play with the model designs. If, you know, they donate access to their system, then they get beta users, and we get people who are now playing with networks that are modeled along some of the things we talked about today, so that we don't have to wait till we're actually flying CubeSats to really be doing this. That would be one thing to look in, is to go from the partnering point of view and just how flexible is their system as a modeling environment. Abraham?
Yeah, I'm going to share my screen. How do we get that again? Do we get it?
You're there.
Yeah, that goes to some of the modeling that we were talking about, Michael, some time ago.
Yes.
This was the model technical architectures, and then there are lots of independent what do you call factors that weigh in, like policies, principle, preferences, and propositions. And then it's kind of talking about transaction processing, securities, management information system, and other types of departments that will need certain things, and different types of reference model on the left columns it shows, and the architecture development process, which is probably the SDK is one of those elements there. Then we have different views of the architecture. We need to address things like functional view, computing view, commercial and constructional view, data management view, security view, and user view, builder's view, and communications view. These are some of those things in practice. So when you if you do a systematic, thorough job, and this is one place I thought we could harvest the brains of thousands of graduates about to finish. If each guy takes one of those views, and then a group manager or different university took such the architectural aspects and apply to them, and like you, our group may also kind of weigh in, saying about the utility value, or like, sometimes you carry something, but it's so much overhead, but when you need it, you need it. So these type of justifications will lead us into a huge set of parameters, and I believe you have good handles on optimizing and pick and choose depending upon the situation you're currently faced with. So I see things here and there, but I think with more people like the thinking alike and more or less weighing the similar pain versus gain ratio or cost versus utility ratio, if you apply to them, I think we will be able to come up with something very concrete and solid. But our community has to grow quite a bit. And
this reminds me a lot of the model-based engineering stuff that Pamela and I were working on for DARPA for a short while, and it also reminds me of the little toy cube spacecraft, LunarCube spacecraft configurator that her interns put together. At least as a very basic start for how to put together a model, and then you do a few of the power and mass and information budgets, and start to just start to play around with different configurations. So you have what I see right here is you have a roadmap towards developing a very high fidelity model, but starting with a low fidelity one. And it'd be great if we could put together some of these modeling ideas that we had before and start working through some of the scenarios. I'm to follow on Russell's notion of different competitions and providing tools for people to compete with. I'm wondering if one of these hackathons or Google Summer of Code things might be able to give us a bump up in putting together one of these scenario development tools in an open source way.
Yeah, I think that's definitely something we'll be looking into. Certainly we want to tap into those kinds of communities and give them initially kind of toy problems headed in the direction we're going into, and eventually growing into real problems and solution sets, I think. But yeah, that's something that's definitely come up over the last 6 months or so. One of the speakers at LunarCubes was Space Gambit, who goes to maker fairs and finds space-worthy toys and gives them a little extra money. Creating a program like that for these sorts of ideas is something I definitely want us to be looking into over the course of next year.
Yeah, that sounds good. one thing that comes back to my mind was, the cell phone and telecommunications industry there, they have this notion of the cell phone tower, and from what I understand, there's a whole lot of engineering and capability in those cell phone towers. And I'm wondering, how do you carve a chunk of that out and put it into that 90 to 150 kilogram space in your Loral Systems spacecraft?
Yeah. Yeah, that would be interesting.
Because there's a huge amount of computing power on the cell phone towers.
Oh yeah, they do lots of very interesting things. The most powerful ones in places like Manhattan also use superconducting from our point of view, spectrometers. The packet switching is all done with superconductor because in a microwave frame they can be very, very efficient, apparently very fast as well. So lots of cool technologies to look at, and I think that's another example of a process that's not going to organically come out of anything NASA's doing or anything pretty much any other government program is doing. And so that's one thing we want to create through the SIGs and the workshops, is this direct retraining of the cutting edge of communications for use in deep space. I'm going to have to jump off to my next call. Really good work, guys, and I look forward to talking again.
Thank you, Russell. Thanks for coming in.
Bye.
Take care. All right, Russ, back to you, Abraham. Are you still there? Oh, I see Abraham is now muted off. I don't think I did that to you.
No, I did it myself.
Okay.
Oh, yeah. So
that was an interesting discussion. Went by quicker than I thought.
Yeah, we did cover quite a lot of grounds, and I just wanted to kind of quick past some of the things which I'm still working on. Something like the lunar network space segment, and some of these use of existing resources and practices, receive only ground stations, and additional resources available in many different orbits. And this is where you can have brought in a huge array of complications.
Hold on. Let me pull you back in. Okay, there you go.
Okay. So if you, what was I saying? Like, it adds to the complexity, but if you look at them as little resources that can help you communicate the things, then the pain versus gain is phenomenally beneficial. So I'm kind of working on a few different models of ground stations for the downlink, and how do we get into the uplink, and then we define things like operation center, and what the types of databases we'll need, what the type of server packs we'll need.
Oh, this is interesting.
And so on. So maybe offline, if we have some time, I wanted to kind of mind share with you, so that I get sometimes stuck on the monotony, So
well, I've been looking into some modeling technologies, and I've been wanting to get a project going so that I could pull up and do some semantic web type things and start to work on some of those technologies. Coming up with some schema and setting up some models for the different components that you were talking about, and then coming up with a model-based way to put together some scenarios, that might be something we can do reasonably quickly, particularly at a fairly low level of fidelity, and then maybe we can start to just start to see what some of the technical ramifications are for some of these configurations.
Absolutely, yeah. I'm 100% on board with you.
Okay. Yeah, it'd be nice to get some funding to get some real muscle behind this, but perhaps we can get some very simple models going first.
Yeah, true. I definitely recognize that limitation we are challenged with right now.
Mm-hmm.
And like now, I have to pretty much right from the time we come back from the workshop until now, and I still have to, some of the doodling thoughts on the head. I have to put that before they evaporate. Okay, and then
Yep.
do sanity check with the enhancements and stuff like that. In
Right.
the
And yeah, when we're putting together the website and have all those action items for that too. So there's plenty to
Exactly.
do.
Yeah, so plenty to do, and like you already identified, like resources and funding are a crunch at this time.
Right.
But in spite of all that, I think we are doing pretty excellent.
Mm-hmm. Yeah, I have to write some. I have to write some notes to Chris Craddock, who is teaming up with Deep Space Industries, and I'll send folks from LunarCubes workshop because some interesting things are happening now.
Okay.
All right. Anything else before we go on?
No, I think we covered quite a bit, and somehow uh, certain things I would like to not discuss in public. So find yourself some time, and let's kind of connect you and me offline.
Okay. Sounds good.
Excellent. Bye.
All right. Thank you, everybody, for tuning in. Hope to see you next time. Next Tuesday at 11 a.m. Pacific time.